So as we add heat to water, the water molecules begin moving faster, and some of them spread out and form a gas. We call that gas water vapor, and that's what's inside the bubbles you see. These bubbles rise to the surface, and this is what we call boiling. So we'll start with the water molecule. The red is oxygen, and the two white atoms are hydrogen. That's H2O. Water molecules are always moving. When we add heat, they move faster. And if we add enough heat, they'll spread out and they'll form a gas. We call that gas water vapor. Note that there's nothing between the atoms here. The black is empty space. To understand why bubbles form during boiling, imagine a group of water molecules, and as you add heat, some of them spread out and form a gas, water vapor. When they spread out, they push the molecules around them away, and that forms the bubble that you see. That bubble rises to the surface. That's boiling. Remember, there are only water molecules in those bubbles. They're very energetic water molecules in the form of a gas, which we call water vapor. Boiling depends on the amount of pressure around the liquid. On Earth, the atmosphere is what creates this pressure. If we look at a cross-section of the atmosphere, only 50 kilometers has enough air for humans to breathe. The pressure also decreases as we go higher. That's because as we go higher in the atmosphere, there are fewer air molecules. Like all matter, air has mass, and gravity pulls it towards Earth. That's why the atmosphere doesn't just drift away into outer space. The weight of the air above us pushes down due to gravity, and this creates atmospheric pressure. The more air above you, the more pressure, and pressure makes it more difficult for boiling to take place. Think of it like these books. The more books, the more pressure. And the more pressure, well, eventually, it'll crush the can. When you go up a mountain, there's less air above you pushing down, and the pressure is lower. Your ears can pop, and water boils at a lower temperature than it would at sea level. So back to boiling. Boiling happens when water molecules have enough energy to spread out and to form bubbles. These bubbles rise to the surface and they release the water vapor. Since the water vapor contains these more energetic molecules, releasing them into the air cools the water. So here we have our beaker with a bubble. If we increase the pressure, the molecules in the bubble will move closer together and eventually they'll change back into liquid water. Alternatively, if we decrease the pressure, that makes it easier for those water molecules to spread out and form a bubble, and that's boiling. We can see this with the syringe. We push in the plunger, we increase the pressure, molecules move closer together, and the bubble becomes smaller. When we pull the plunger out, we're decreasing the pressure. That means those molecules can spread out more easily, and the bubble grows. If we pull the plunger out and decrease the pressure enough, water will start boiling. Note that the temperature doesn't change. It doesn't get hotter when it boils. It's just that there's low pressure, the molecules can spread out to form bubbles, and that's what we see happening here. Boiling is strongly influenced by the atmospheric pressure. On Earth, that pressure is created by gravity pulling air molecules down towards Earth. Those air molecules push on a liquid, and they can make it more difficult for boiling to take place. Remove the pressure, and it's easier for boiling to take place as the more energetic molecules spread out and form bubbles. Note that we haven't talked about the pressure created by molecules of water escaping the liquid. That's called vapor pressure and the subject of the next video. We know that boiling is strongly influenced by atmospheric pressure. Pulled down by gravity, the air above us creates pressure, and that makes it difficult for bubbles to form and boiling to take place. We can think of atmospheric pressure as the collisions of air molecules against the surface of the water. That's the pressure. The more collisions, the greater the pressure. But water molecules can create pressure when they leave the liquid. As these faster moving water molecules escape, they collide with the molecules of air. This creates pressure, and we call it vapor pressure. In a way, the water molecules are pushing or colliding against the air molecules. This reduces the amount of pressure felt by the water. Back to boiling. Textbooks often state that when the vapor pressure equals the atmospheric pressure, boiling takes place. This is called the boiling point. Think of it this way. atmospheric pressure pushes down, and that makes it difficult for the water molecules to spread out and form a bubble. But when the vapor pressure increases, molecules from the liquid escape, and they push against the air molecules and effectively reduce some of the pressure. This makes it easier for the liquid molecules to spread out, form a gas, and to rise to the surface. That's boiling. We can make boiling happen by either increasing the vapor pressure or decreasing the atmospheric pressure. Either way, once the vapor pressure and the atmospheric pressure are equal, we've reached the boiling point, and boiling can begin. One last thing. Different substances have different vapor pressures, and therefore they have different boiling points. This has to do with how strongly the molecules are attracted to each other in the liquid. The more strongly they're attracted, the less the vapor pressure, and it's more difficult to boil. Therefore, the higher the boiling point.